This is the second part of my first-person horror game tutorial. In the first part, we went over scene setup and created the first-person character controller. In this one, we're going to cover lighting and give our player an objective. So let's get right into it. So, lighting. I'll be real, I hate Unity's lighting system almost as much as I hate its terrain system. You would think something like make scene dark would be simple and straightforward, but that's not really the case. Darkness options are separated into odd locations, making it difficult to find what to change to make everything darker. Like if I change the sun's intensity, for some reason the skybox and world are fully visible. If I go into environmental lighting and reduce the environmental lighting intensity multiplier, it darkens the world, but the skybox is still clearly visible. So I have to go into the skybox material to reduce the exposure or change the color to darken that as well. Yet the fog color isn't affected by the lighting. This is all pretty annoying, but we can simplify it by creating a script that controls all of these values. So create a new script and call it day-night controller. Open up the script. We'll just be accessing the values we discussed earlier and adjusting them based on the time of day. The execute always attribute will ensure that the script runs both inside and outside of play mode. Let's start by creating a serializable struct called range, which we will use to define the min and max range for each light source. The serialize attribute will allow Unity to display this in the inspector. Create the min and max float fields and add a constructor that sets both of them. Add a method called lerp. Lerp is short for linear interpolation. If you don't know what this is, here's a quick explanation. It's essentially getting a value between point A and point B based on an interpolation factor, which is usually a number from 0 to 1. So if A is 10 and B is 20, here's what the value would be based on T. This can be done in a single line with mathf.lerp. We're going to need an inverted version of it for some cases, so let's add that method as well. We want to be able to compare ranges, so add an equals method that checks if one range is basically the same as another. Let's override the equals method to improve comparison. For this to work properly, we also need to override the getHashCode method. Don't ask me what this means, I have no clue. Finally, add a custom equals operator so that we can compare two ranges with the equals sign. We also need to add the not equals counterpart. And that's all for this struct. Add a header called lightRange. We're going to need a reference to the sun, so let's add that. Add a range field called sun lighting range. The 5 is just the value our sun intensity was on. Don't worry too much about the precision here because we can just change these values later. Create a private range field called previous sun lighting range, which we will use to see if the value has been changed. Add another range field for the sun's rotation. The sun's rotation was around 22. I'm just adding 180 to the max so that the sun is on the opposite side of where it started. Again, let's add a private range field for it. We're going to have to do this for each one, by the way. Now let's create one for the environmental lighting. Earlier we saw that our environmental lighting started at 1, which will be our max value. And setting it to 0 makes it the darkest, which is why it's our min value. Skybox exposure is another one, so let's add that. Again, we checked earlier what this value was. It was a really small number, but despite it being so small, it's our max value. Also, we don't want 0 to be our min because it was too dark. I do want some of the skybox to be visible. Now add a header for the fog range. We didn't really try the fog settings, but it was there in the lighting window. We are just going to make the fog color change from white to black. So add a color field for the color of the fog during the day and set it to equal white. Add another color field for the color of the fog during the night and set it to equal black. Add a float field called fog density that will control the fog strength. The range attribute just creates a slider in the inspector. We just need to add one more that will control the current time of day, so create a header field called day-night control. Create a range from 0 to 1 and add a float field called time. Just like the others, add a previous time as well. That should be all the fields we need. Now add two methods, one called update and another called update environment. In the update method, we'll update the environment whenever a value is changed. But if there's no sun reference set, then just return. This is going to be a pretty large if statement. We're basically checking to see if any of the values have been changed by comparing them with their previous values. If any of them have been changed, we will update the environment and set each previous value field to the new one. In the update environment method, use the lerp and lerp inverted methods and pass time as the parameter to get the value at the current time of day for the sun intensity, sun rotation, environmental intensity, and skybox exposure. Color has its own lerp function, which we can use to lerp between the day and night colors. Now that we have all the lerped values, let's apply them to each object. Okay, that's all for this script. Now switch back to Unity and create a new empty game object, call it day-night controller. Add the day-night controller script. Drag and drop the sun into the sun field. Alright, now we can go ahead and test it. Just change the slider and it works. By the way, if setting the time to 1 doesn't make your scene pitch black, go to Window, Lighting, turn off Baked Global Illumination and then clear baked data. You can try to find the best settings here. Having the night fog be fully black may not be the best idea. Personally, I like it on a dark gray so that the distant environment is just barely visible. I understand it might be difficult to see anything in the dark right now, which is why we're going to create a flashlight. So if you imported the Unity package from the description, you should already have a 3D model for the flashlight. I prepared these assets just for you guys, so I'd appreciate it if you hit subscribe. Drag and drop the flashlight model into the scene as a child of the camera target object. Adjust its position and rotation so that it's near the hand area of the player and facing forward. Enter play mode to test it out. Now we just need to add light. Add a spotlight as a child of the flashlight. Rotate it so that it matches the rotation of the flashlight model. Move the light up to the lens of the flashlight. Increase the inner and outer values. 40 and 80 work pretty well. Increase the range and intensity by a lot. I'll go with 100 range and 1000 intensity. Also, we want our flashlight to cast shadows, so enable soft shadows. Now make sure it's nighttime and enter play mode. We can finally explore the world during the night. If you're not happy with the light settings, feel free to adjust them. Try to find the values that feel right to you. If you remember from the previous part, we added a flashlight input key. We haven't coded that yet, so let's do that right now. And don't worry, this will be very simple. Create a script called flashlight. Open up the script and add a light field called light source. And create a method called toggle that simply toggles the enabled state of the light source. Give the script to the flashlight object and drag and drop the light into the light source field. Now go back to the first-person controller script and add a flashlight field. In the onFlashlight method, simply do nothing if the flashlight reference has not been set or control is disabled, otherwise toggle the flashlight. In Unity, click on the player and drag and drop the flashlight into the flashlight field of the first-person controller. Enter play mode and give it a test. Just like that, we have a fully functional flashlight. And that's all for lighting. Now, we don't want our player walking around with no goal in mind, so let's create a simple goal. So the goal will be to get to shelter before you get caught. Let's start by creating a simple defeat and victory screen. Add a new text object by right-clicking in the hierarchy, navigating to UI, and selecting text. If you get this message, simply click Import TMP Essentials and then close it. Let's add an image. This will be the background of the results screen. Make it fit the screen and then set the color to a transparent black. Make sure the text comes after the image so that it renders over it. Now select and center the text. I'll just write default text for now. Increase the font size to something reasonable. Let's also add a small border to it. Alright, now we just need to create a button that will reset the game. Right-click on canvas and create a button from the UI options. Move it down and adjust its size. I'm just going to name these objects appropriately. Change the text of the button to replay. Enable auto size and add some padding as well so that it's not too close to the edges. So now we need a script that will handle the showing and hiding of this result screen. Create a new script called result screen. Before we can start coding, let's just rename canvas to result screen and give it the new script. Open up the result screen script and remove the default methods. Now that I think about it, this is more of a title than a label. Start by adding the UI namespaces that we'll be using. Create a header called controllers and add a reference to the player controller. Add another header called UI. Create a text mesh pro field called result title, 2 string fields for the victory and display text, and a reference to the replay button. Add a private field called player start position that we will use to return the player back to their starting point when the game is reset. Now on awake, we'll make the player's start position equal to the current position of the player. The replay button should be resetting the game on click. Before we get to that, let's create the victory method, which will display the victory text, and end the game, which will be another method. Create a method called defeat, which is similar except it'll display the defeat text. Once the game has ended, we'll make the cursor always visible. Disable player control and display the result screen by enabling its game object. Reset game will hide the cursor once again, hide the result screen, re-enable player control and make the player teleport back to their starting point. Just one last thing, make sure the result screen is not visible at the start. That's about it. It's a logically very simple class. So if you imported the Unity package from the link in the description, you should have a model of a hut. This will be where the player has to reach to win the game, so let's add it to our scene. We'll keep it fairly close to the spawn point for testing purposes. Select the hut and add a box collider. Adjust the size of the box to match the hut if it doesn't already, and set the isTrigger value to true. Now let's create a script called finish zone. Give this script to the hut. Open the script. Don't worry, this will be a very small one. But first, switch to the result screen script and add a static result screen field called instance. This will make it easy for us to access it from other scripts. In awake, set instance to equal this. Now go back to the finish zone script and add a method called onTriggerEnter. This method is triggered by Unity when the object collides with another if the object has a collider with isTrigger set to true, which is what we did earlier. All we need to do is check if the player has collided with the object. If so, display the victory screen. And that's all we need to do. And now we can enter play mode and test it. Perfect, it works. Pressing the replay button puts me back to my starting point correctly, which is great. Since we now know it works, let's put this somewhere far away. I'll place it in some random location inside the forest. I'm not sure if this is a little too far, but it's probably fine. You could have multiple huts around the map by creating copies of it if you want to. You could also randomize their positions per play, but I'm just going to leave it here for now. Anyway, that's all for the goal, which means that's also the end of part 2. In the next one, we'll be going over the hardest part, which is the enemy AI, and then we'll end it on a high note by adding sounds. Like the video if you learned something, subscribe for more content like this, and if you have any questions or video ideas, let me know in the comments down below. My name is Esper, and that's all from me for now.